Hi, everyone. Good morning. My name is Chris Jesnak, and today I'm going to talk to you about reducing cost and time to market of lithium-ion battery systems using digital manufacturing simulation. There are four topics we'll cover today. First, we'll take a look at the EV electrification market and provide some context, background on lithium-ion battery systems. Second, we'll provide an introduction to the investment landscape and why certain players win over time in a fast-paced developing market. And third, we'll look at key challenges of product launches and how they can be overcome. And then fourth here, we'll learn how digital manufacturing simulation can help solve key challenges of product launches in a battery system. Before we get started here, just a little bit of an introduction and background on me. And so as I mentioned, I lead up the product marketing team at A Priori. And prior to joining A Priori, I've worked at various manufacturers, including Sensata, a sensor manufacturer, Spiral, an engineered fastener manufacturer, and also ExxonMobil, an energy and chemicals producer. With today's topic, my experience at Sensata is most relevant as I led product marketing and strategy for key components found within lithium-ion battery systems, including high voltage contactors under their Gigaback brand and battery management systems under Lithium Balance brand. But enough about me, let's go ahead and get started and take a look at EV growth to begin with. So here we're showing electric vehicles and their growth projection from 2020 to 2030. They're significantly growing over time if you look over 10 years, and it's across various markets, from vans and trucks to passenger cars, buses, 2 and 3 wheelers. And so you can see here, looking at different examples, and I'll look at the passenger cars example in detail. In 2020, about 4% EV share of sales, growing to 34% projection by 2030. And there's two different cases here. There's a 34% assuming kind of an economic transition scenario, and also a net zero scenario that assumes additional policy measures will be put in place above and beyond what's out there in 2020. And so that 24% is on top of the 34%. And across the block here, you can see the mix and growth across all different markets, not only within the automotive passenger car space. The reasons for this growth and different factors driving it really have to do with three main areas. And the first is on rising policy pressure. We can see here on the left, there's a number of countries that have announced plans to phase out sales of internal combustion engines, 15 countries and 31 cities and regions. If we all remember last year's Super Bowl, there was a particular memorable commercial for me from General Motors, and it was with Will Ferrell. And he was comically talking about EV adoption in Norway and how it compares perhaps to the US. But if we take a look at that and look at the reasons why Norway may be adopting EVs per person versus some other countries, one of the reasons is infrastructure build out and putting policies in place to get there faster. Other regions and countries might have to make certain investments to keep up. And for one example here, President Biden has announced in his jobs plan, including a major investment to fund and build out a national network of charging stations. Consumers will expect a similar experience to what they have today. And so with this build out, it will certainly help with future growth and adoption. And then third, battery technology and cost. It's come down nearly 89% from 2010 to 2020. And it's only going to come down even more as these scale in units and volume over time. If you look at that, about 30% of the price to consumers is what the battery pack makes up. It's the single most expensive part of an EV. And because of all this and the growth, there's significant investment that's taking place across the market. If you look at both with established leaders and also emerging leaders. If you look at the end market here on the left, from the automotive side all the way to aerospace and defense, there's key investments that are being made by established leaders. General Motors announcing 30 new global EVs by 2025, 35 billion investment in EV and autonomous tech by 2025. If you look at the truck and bus space, Daimler Trucks saying that nearly all vehicle development will be focused on zero emission vehicles by 2025. And then similarly, material handling, Kion Group, one of the global leaders, is expecting that lithium ion will make up 2/3 of electrified trucks by 2027. And then Boeing, just one example in the aerospace and defense sector, saying that they support reducing costs of battery systems with investments, and one strategic investment in electric power systems. But not only with established leaders, there's also investments taking place across the board with emerging leaders from different SPACs, special purpose acquisition companies. And you see here in the automotive space, Lucid Motors, but also Rivian, estimating maybe that IPO will be 50 billion plus, to truck and bus space with Arrival. And then all the way down to aerospace and defense, two examples here going this public route via SPACs, this Vertical and Archer. One of the reasons why all this investment is happening is because this is relatively new. There's new technology that's coming out. So let's take a look at an EV lithium-ion battery system and what it consists of. If we take a look here on the diagram on the right, one of the first elements to building a lithium-ion battery system is starting with your chemistry or your battery cells. And these can come in different forms, cylindrical, pouches, or prismatic. Typically, those are packaged together and then put into what's called a battery module. Battery modules are then put together, which make up the overall system. And that system could be referred to as a battery pack, or in some cases, depending on the vehicle power requirements, you could have multiple battery packs, sometimes 4, 8, or even more, depending on whether it's a fully electric truck, bus, or similar larger type of vehicle. If we take a look at that, typically the cells contribute to the majority of the battery cost. But there's other really important areas that also can add up. And one in particular that we're going to take a look at is the battery management system. Studies show that can contribute over $1,000 to the lithium-ion battery system. But let's take a look at some numbers and look at the overall cost and the cost drivers associated with a lithium-ion battery pack and system. So as I mentioned, cells are typically the largest driver, but there are other areas that provide cost reduction opportunity. So the chart on the left shows dollars per kilowatt hour for some leading EV OEMs in the market. Here we show Tesla, General Motors, and then an average across other OEMs together. Tesla coming in total dollar per kilowatt hour, slightly below 200. GM, you see, is slightly above 200, and then the other OEMs just shy of $250 per kilowatt hour. Then if you look at the breakdown, the way we have this segmented is in the blue, the battery pack other category can contribute up to 24, nearly a quarter of the total battery cost, but the cells by and large about 3/4, 75% of the overall cost. That will continue to reduce with new cell technology and scale, but the opportunity and an example that we're going to look at today is beyond the cells. What are the opportunities for savings? And we have some examples later on in the presentation of how that will happen. But beyond cost, how will emerging players win and capture market share over time? What we found is those who can launch products that meet not only cost, but major time milestones as well. In a fast-moving, developing market, beating out competition in terms of when you launch product might help you be an early mover and get market share early on faster than others. Designing and hitting performance targets is another important area in terms of meeting product launch goals. And then lastly here, meeting cost and profitability targets. But how do companies do that when there's so much investment and so many players in this space in such an evolving market? The chart on the left shows a study done by McKinsey on different spaces within the automotive sector and investment areas. And the top right shows a cluster diagram. And you can see overall the density in the electrification area. The higher the density, the more investment that's happening in that space. So how do players and companies compete over time and overcome key challenges? So some of the key challenges we've seen within product launch goals on the left-hand side here, on the first area, meeting time milestones. You have three bullets for each of the areas here. We're just going to focus on the bolded area. And one of the key areas in terms of challenges to meeting time, having access to relevant and accurate data. It's difficult to compile. It's coming from different sources. In some cases, it might take weeks or months even to get access to the right data, information from suppliers. On the product launch goal related to meeting design and performance targets, one of the areas we found and challenges is that value engineering work is often saved for post-launch. How do companies start to get that value engineering work faster as design teams are working around the clock just to meet base level design and performance targets? And then last, on cost and profitability targets, we've seen a lack of cross-functional collaboration tools, and inability of having something to collaborate across the entire value chain contributes to inability to hit overall product launch goals. Let's take a look at how digital manufacturing simulation as a product cost and manufacturing insight solution can help, and how it fits overall with today's landscape and software tools used in the market. So take a look here. What you see visually is the new product development value chain, starting with sales and quoting, going to design, sourcing, manufacturing, and then value and cost engineering. If we take a look first of how companies start typically when you go after new opportunities, you typically want to find a way to manage and track sales opportunities. And that's done with your CRM or customer relationship management tool. Next, companies look for different tools to design and analyze product capability. Two examples here, computer-aided design and then computer-aided engineering. And then third, software that can help manage product lifecycle. And so from the overall, starting with the beginning to end here, product lifecycle management or PLM is often used for that purpose. And then next, the ability to plan and manage manufacturing. And your ERP, enterprise resource planning, or supply chain management, SCM software is typically used for this purpose. But what is not as ubiquitous today as some of those other areas is software used for product cost and manufacturing insight. And that's what we're calling digital manufacturing simulation. And there's key benefits and features that this is providing along each step of the value chain. Starting with the sales and quoting side, providing accessible and more accurate cost detail. To design, having automated DFM, design for manufacturability, and DTC, design to cost insights. To sourcing, fact-based negotiation using as a should cost tool. To manufacturing and value engineering, having a tool that's easy to use, not only within these areas, but for the other stakeholders across the board. And having a collaboration tool, not only that cost engineering teams are using, but other areas and functions in a company are using as well. And last but not least is the ability and opportunity to integrate with existing software today. CRM, CAD, PLM, and an ERP system. So these all fit in and fit right into the three goals of launching products: meeting major time milestones, meeting design targets, and meeting target cost and profitability. So next, we're going to take a look at how digital manufacturing simulation speeds up the product launch process using an illustration. So if we look at an example, now getting back specifically to EVs and lithium-ion battery systems, typically it starts with the OEM defining their product goals, product design, and then getting into sourcing, how we're actually going to source, which suppliers we're going to use. And then once they start the sourcing mode, then it gets to the supplier. And this example could be the lithium-ion battery system, various sub-suppliers within that space. They'll start with quoting. And before they're able to quote, need to think about how we're going to design this product, how we're going to manufacture the product, and also how are we going to reduce the cost overall. And then third, once it then a supplier is selected, then goes to the OEM and start thinking about how we're going to assemble. So if we look at an illustration on the product goals and the OEM side, profitability and cost targets are often developed and thought about first. So if we look at the illustration on the bottom here, we just put OEM cost target for illustrative purposes on the left. And then as it moves along, maybe it gets to the supplier and they come up with a target cost, maybe using a different tool, different method. We'll just put it here to the right for now. And then what happens is they go and quote it. Maybe it is pricing that's developed based on cost. Maybe there's other means of how they come up with their pricing. Put the supplier quote all the way on the right-hand side here. And when you look at this diagram, the OEM is going to have a certain willingness to source and perhaps not go above this line shown here. And the supplier is also going to have a willingness to quote. Maybe they don't want to go below this line. The ability to tighten that gap and the closer that is really will help result in success and be able to get through the process faster from an OEM and also supplier perspective. So how do companies gain confidence to tighten that gap? Either the OEM moving to the right or the supplier having willingness to move to the left. More often than not, there's several rounds. Suppliers might go through more than one round if they're lucky, maybe 2, 3 if they have really good, strong performance and design targets, but that can really add to the time of an OEM be able to launch on time. So you might go through several rounds, but one way in order to reduce that is using digital manufacturing simulation to tighten this gap here and look for design to cost, design for manufacturability insights to reduce overall. And so with this, and we're going to show an example here in a battery system, suppliers and OEMs can move their cost targets to the left. So we're going to take a look next at 3 uses of digital manufacturing simulation for lithium-ion battery management systems. And so in the diagram at the beginning, we talked about the overall battery management system, and it's one key area within the overall battery system. And we're going to show 3 use cases. First, looking at how it can be used for fast and accurate product cost simulation. Second, on design and manufacturability insights. And then third, on automated cost and manufacturability insight. Before we do that, it helps to just set the scene and provide a little bit of background of what actually is in a battery management system and battery disconnect unit. So if you break down a battery management system, I'm going to call it here as BMS, over on the right-hand side here, you'd find that it contains software that's often embedded on a printed circuit board, but it also contains sensors to read out current, voltage, and temperature. And the main purpose of this is to really ensure that the battery is operating safely and optimally performing from a state of health and state of charge perspective. Although scaled up quite a bit in terms of voltage and current levels, it's somewhat similar to the ability of your phone to read out state of health and state of charge when you go into diagnostics. And then in some architectures, there's another product called the battery disconnect unit that can be combined with the battery management system, but this ensures safe power distribution and switching capability and providing high voltage and current disconnect functionality. If you look at these, sometimes the BMS or the software embedded on a PCB can be integrated directly into a battery disconnect unit, and sometimes vice versa. Some common components within the BMS or BDU, if you look at the bottom right, can include high voltage contactors, current sensors, different fusing products, could be thermally or maybe using a pyrotechnic device, connectors, PCBAs, wire harnesses, bus bars, and then some type of housing or enclosure, often with a certain IP rating. All right, so let's take a look at the 3 use cases, starting with providing fast and accurate product cost simulation. Here's an example using a housing. On the right-hand side here, a housing or enclosure for a battery disconnect unit. Digital manufacturing simulation software can instantly and precisely determine the cost from a CAD model. And so in this example, maybe a designer is thinking about switching from injection molding to another area, or from die casting to injection molding. And in different scenarios can easily see how much that switch might be able to save in terms of cost savings. And doing this with a cloud-based platform enables global teams a fast way to iterate. Use case number 2, still sticking with that same component, looking at the housing. Here looking at designed for manufacturability insights. What this software can provide is overall design guidance, giving a DFM risk, high, medium, low, and giving guidance issues, and the ability to look at a certain number and prioritize those. In this example, although showing a simpler example here of an enclosure with sharp corners and how the software would be able to give insight to say, maybe think about putting a radius on those corners and rounding out the edges, providing insight and quick tips of how to do that as a manufacturer and someone in manufacturing actually going to make the product, and providing helpful links of how to actually give some insights and industry common practices. And then third, not only just looking at the housing, but now looking at the overall bill of material within the BMS or BDU, the ability to automate manufacturing insight. Looking at the right-hand side here, looking at the 5 steps, checking your CAD into your PLM. You can automate costing of these checked-in parts, and it can work behind the scenes. Design engineer can come back into the office, tomorrow and see that report of how it's prioritized, and now start to look at the key areas of concern. So in summary, looking at digital manufacturing simulation and the benefits of using it within a lithium-ion battery system helps to launch products that can meet major time milestones, meet cost and profitability targets, and also meet design and performance targets. Now, I want to leave you with one quote here from one of our customers. Using the a priori software, we've created 26,000 simulations in just 6 months. And the best part is that we don't have 26,000 spreadsheets. Thank you for your time and opportunity today. I'll be around for questions. Thanks again.